Hi everyone, so this is problem 4 from problem set 9. If you want to look at this is the problem I'll be doing, but I am going to take it away in a minute, so you might want to have it pulled up somewhere else. I do translate the values over to this Excel sheet, but the actual questions won't be there to look at. Okay, so first we're going to head to this Excel sheet that I created. I think it's really helpful to create a table that you can put the values into and kind of look at what you're missing, and then that pretty much will help you figure out which variable you need to solve for in these problems. So I first started by locating the formula that I'd be using for every single one of these sub-problems. It's just going to be manipulated or changed a little bit. But so basically this is the formula to calculate the future value of a single amount. So it has future value equals the present value or the principal amount invested or put away, and then you'd use 1 plus the interest rate, which is I, and that would be put up to the number of periods of compounding interest or the number of years. So for this first subproblem A, we have a amount deposited of $9,750 at an interest rate of 12%. It's going to be compounded annually. The day it was deposited was January 1st, 2000, and what we're solving for is the accumulated amount, which you'll see below, and the date that you decided to withdraw the money is the 1st of January 2017. So if we come down here, we have how much is accumulated by January 1st, 2017. So basically what I've done is just rewritten these values down here, and then this is basically what I've inputted right here. That's going to help me find the value of this. In this case, it would be the future value. In order to make it a little easier, I've drawn out the formula here. This one's not as complicated, but as you can see, they get a little more complicated later on. So basically for this one, it's similar to what we have over here, just future value equals the original amount multiplied by 1 plus the interest raised to the amount of years that you've put it away for. So this one's simple plug and chug. So you can see here I've put in the original multiplied by this interest rate plus 1 up to 17 years, which is the 2000 to 2017. So that's 17 years. This will give you an accumulated amount of money that equals $66,943.90. Okay. So problem B. What rate of interest did Mike earn on the deposit? So this one we're solving for something different, but we're still going to be using this exact same equation. Okay, so the original amount you deposited was $21,600. It's compounding annually, so we know we're going to be using this formula. You deposited it in January 2007, decided to take it out in January of 17, which means you have 10 years that you've been compounding this interest. Your accumulated amount is going to be $42,486. Okay, sorry, $42,486 is your the future value of your money. So what you don't have is this interest rate. So I'm going to go back to these drawings, which make it just a little bit simpler to see how I've shifted this around. You need to get the interest rate alone. So in order to do that, you have to first take this P, move it over, and divide future value by the original amount. That's going to leave you with this 1 plus the interest rate raised to the n on the other side. So basically what you're going to do is, take this and in order to get this, plus I. You want to solve for this I. So you're going to take this n and move it over to this side. So what it would look like is FV divided by P to the n. But to make it a little easier on our calculators, I've just moved it to what I have over here, which is this 1 over n, and that makes it easier to plug in. And then last but not least, you still have the 1 plus the I, so you would subtract the 1 over, and this would leave you I on the other side. So there's that. We'll go back to this. So basically, you can see what I've done here. Same thing you just saw, but this is in Excel format. Make sure you have the 10 years put here. This is the future value divided by the original amount raised to 1 over 10, subtract 1. That's going to give you 0.069, or I rounded up, 0.07, which is a 7% interest rate. Next, we have how much money did Lee originally deposit on January 1st, 2010. We'll head back up to the chart to see which variable we're missing. So it wants to know how much he originally deposited. It gives you the 8% interest rate compounded annually. You know that you're going to have 7 years that you're looking for because you originally deposited in 2010. You're going to take it out in 2017. And the accumulated amount they give you, and it's $15,000. So you're going to come back down, still using the same exact equation. This is what it's going to look like when we put it into Excel. These are the values again. I'll pull this up real quick so you can see. This one is pretty simple. You're solving for that original amount. So let's see. We'll come back, bring this up here so you can see it. Basically, I've just taken everything that's to the right side of this P and divided the FV by it, or you're going to divide FV by the 1 plus interest rate raised to the amount of years, and then it just becomes a simple plug and chug right here. So you plug all these values in, and that is going to give you your P, or your original invested amount, which comes to $8,752.36. Lastly, problem D says how many years has the deposit been invested? So you're going to come back up to this little chart. It's going to tell you that the original amount you invested was $5,800 at a 10% interest rate compounded annually. The year doesn't, you're trying to solve for the amount of years, so like the actual year you put the money in doesn't matter as much. So they just give you random January, they say that it was deposited. And then your accumulated amount is going to be $15,026. Solving for that date, but more just solving for the N, or the amount of years that you've compounded this interest. So we're going to take a look at this drawing, makes it a little easier. So this problem is probably the toughest in terms of like the math of shifting the equation around. You have to get N alone on one side. So if we head back up here, you'll see that we have ln of the future value divided by the original amount divided by ln of the 1 plus the interest rate gives you n on one side. So basically you have to get that n out of the exponent and you have to solve for it. So that would mean taking the natural log of both sides. So in this case, it leaves you with this. Come back, plug in all those values you had originally. Should look something like this within Excel. And that's going to give you 9.98, or you can round that up to 10 years. So this is pretty much problem 4. If you have any questions, feel free to ask. If this wasn't clear, I'm sorry. I did my best. Thank you.